we are on lesson 33, and we're going to talk a little bit about alternating current, of course, as well as direct current, and then also talk about RMS values. Okay, so we've already touched a little bit on AC current as well as DC current, because remember we spoke about AC motors, AC generators, direct current, or DC motors, DC generators. So how would we just get direct current? So imagine that you have a circuit diagram like this here, where it's connected to a cell or a battery. It could be a battery. This is a positive, this is the negative. And then you had a light bulb there. So let's say the power output, the voltage output was 10 volts, the potential difference, and then the current was just 2 amperes. Right. Okay. So we know that conventional current is always from positive to negative. So you'd have current flowing in this direction. So meaning it would go in this direction. So if we were to then say, okay, let us plot a graph of time of current versus time for DC current, right? So we draw our axis, y and x axis, and then maybe we said it's 2 ampere. So time, this is in seconds. Let's say this is 5 seconds, 10 seconds, right? And then we would find that throughout, the current is just 2 amperes. So after 5 seconds, the current is still 2 amperes. It's just that I can't draw a straight line, as well as after 10 seconds. So the current is just flowing in this one direction, right? The same thing could be said about if we drew a graph, a plot of potential difference against versus time. So we have our potential difference, we said it's 10V. After 5 seconds, 10 seconds, it would still be 10 volts. So that battery would still be supplying a value of about 10 volts. Okay, cool. So now, what about AC? Let's try to do a similar illustration for alternating current. So for alternating current, we would find ourselves with a situation such as this one. So we would have our alternating current source. So that's how draw it with that thing. And then there you are. It's connected maybe to a light bulb here. It's powering this light bulb, Okay, cool. So now we have so you find that for at one if we look at this, at one point the current would be in this direction, and then after a while the current would be in this direction, because it will actually, our current would actually form a sort of a sinusoidal function. So we would have something like this. So after every 180, after every 10, half 10, the current would change direction, right? So that's the difference there. And maybe the maximum current supplied would be 2A, and then here we would have the minimum, which is negative 2A. Okay, so the same thing also we can say as well for the potential difference V. It will also be the same. Maybe we'll have 10V here, and then a negative 10V. So this would be what we call Vmax as well as Imax. Thing is that we cannot use this current or voltage as it is. What we actually do is that we define RMS values for both current as well as a potential difference. So RMS simply means root mean square. I'm not going to go into detail about it, because the important thing for you to know are just these equations that I will show you now, that you can find at the back of your question paper, or even in your examination guidelines, or even in your book, physics book. So we will define a number of formulas that you're supposed to know how to use. So we'll have maybe Imax, IRMS, obviously IRMS. I don't like this marker at all, but it's the only one that is working right now. So RMS is given by Imax divided by for 2. So this is for alternating current. And then Vmax, VRMS is given by Vmax over the root of 2. Then also we can say we have the power, the average power, which is given by IRMS multiplied by V RMS. So in the next lesson, actually, when we're doing a question from an exam, you will see how to use most of this formula. And then P average, of course, can also be given by I squared RMS multiplied by the resistance. Another formula there, P average will be given by the V squared RMS divided by R. So you have to know how to use this. They are quite simple, they're quite straightforward. It's just always a matter of substituting it correctly. Okay, so this actually brings us to the end of this lesson. It wasn't a long lesson. I just wanted you to be able to distinguish between alternating current as well as direct current, and understand in terms of alternating current that we actually have to use what is in terms of alternating current to understand what RMS is as well as what Imax is and all of that. So yeah, in the next lesson we're going to just be doing a very quick question from a previous question paper.